Have you ever looked closely at a sunflower, or the elegant curve of a seashell, and felt a sense of profound order, a feeling that its beauty is too perfect to be accidental? You're not imagining things. What you're sensing is a hidden language, a universal code that shapes the world around us. This isn't magic, it's mathematics, the silent architect of the natural world. Our journey into this code begins with a simple sequence of numbers discovered in the 13th century by Leonardo of Pisa, better known as Fibonacci. It starts with 0 and 1. From there, you just add the last two numbers together to get the next one. So, 0 plus 1 is 1. 1 plus 1 is 2. Then 3, 5, 8, 13, and so on, stretching into infinity. It seems elementary, but this sequence is nature's favorite building block. Look at the head of a sunflower. The seeds are arranged in two sets of intersecting spirals. If you count them, you won't find random numbers. You'll find consecutive Fibonacci numbers, like 34 and 55. The same pattern appears in the scales of a pine cone. This arrangement is the most efficient way to pack the maximum number of seeds into a small space. It's a perfect solution for survival. This sequence also gives rise to the golden ratio, an irrational number approximately 1.618, which defines the elegant logarithmic spiral of the nautilus shell. This allows the shell to grow larger without ever changing its fundamental shape. It's a model of perfect, efficient growth. Now let's change our perspective and zoom in on another of nature's mathematical principles, fractals. A fractal is a pattern that endlessly repeats itself at different scales. It's a property called self-similarity. A rugged coastline, for instance, looks just as jagged and complex from a satellite as it does from a few meters away. The most striking example is Romanesco broccoli, where each tiny floret is a perfect miniature of the whole head. Nature loves fractals because they are incredibly efficient for covering surface area or transporting resources. The branching of our lungs, the network of rivers, and even the chaotic beauty of a lightning bolt all follow fractal logic. They are solutions to the problem of how to be complex and efficient at the same time. Finally, there's the simple, yet profound, concept of symmetry. It's everywhere. Bilateral symmetry, a mirror image across a central line, gives a butterfly its balance and a human its familiar form. Then there's radial symmetry, where patterns repeat around a central point. Think of the 5 arms of a starfish, or the delicate 6-fold symmetry of a snowflake, a direct result of how water molecules crystallize. And in the hive, honeycombs demonstrate the power of tessellation. Bees instinctively build hexagonal cells because it's the strongest, most compact shape to store the maximum amount of honey using the least amount of wax. It's a masterpiece of natural engineering. The Fibonacci sequence, fractals, and symmetry aren't isolated tricks. They are interconnected threads, woven together to form the very fabric of our universe. From the microscopic to the cosmic, these mathematical principles govern growth, form, and function. Mathematics isn't just an abstract subject of numbers and equations, it's the code that nature writes in, the blueprint for life itself. And once you learn to see this code, the world becomes infinitely more astonishing.